Welcome back, Honors Algebra 2. We are doing 2.2 today. It is some handwritten notes, so make sure you have your notebook out. Pause the video if you need to get that going. A lot of this should be review today for you. We're talking about slope and rate of change. As you guys should have learned in Algebra 1, slope is just the ratio of the vertical change to the horizontal change. So if you think about that, what we're talking about is that it's the ratio of how high it's going or low, and then over how much it's moving left or right. So vertical change to horizontal change. Alright, so, and this applies to not just x's and y's, but anything. For example, rate of change is referring to any real world situation. I could say that for every $5 I increase the price, the demand for an item goes down by 3 items. That is a rate of change. So anyway, some notation. We use m for slope. Again, we use rise over run. That's what it stands for. And another way to write that is change in y over change in x. That's what those triangles mean. They are deltas, which means change. And the formula that you guys are probably familiar with is y2 minus y1 all over x2 minus x1. So the second y coordinate minus the first, and that's if we have the points x1, y1 and x2, y2. So let's just do a quick example, because there are 2 ways I actually like to find the slope. This way, and then there's another way. It's basically the same thing. So we're going to find the slope of the line of through the points. Let's see, we'll go through the points -3, -2 and 5, -1. Alright, so 2 ways. The first one, you can use your equation up here, y2, y1. So I could say that this is y2, and this is my y1, and then these are my x's over here, x2, x1. So my y2 would be -1. So my slope is -1 minus a -2 all over 5 minus a -3. So -1 plus 2 is 1, and 5 minus a -3 is an 8. So the slope is 1/8. Now here's another more visual way to do it. It's called the jump method, not the jumper method. What you do is just write the points on top of each other. -3, -2, that's 1 point. 5, -1. And this is basically the same thing as using the formula. You just look at the change. Look at these changes. To go from -2 up to -1, we went +1. To go from -3 all the way up to +5, we went up 8 units. This is your y change, this is your x change, so we always take the right-hand sign over the left-hand side, which turns out to be 1/8, which is the same thing as what we had before. You can use either method, I don't care. I sometimes tend to do the second method just because it's sometimes faster visually for me. So, alright, good. Now, let's talk about what these different ones look like. If you have a positive slope, you have a picture that looks like this. It's rising as it goes to the right. If you have a negative slope, it's falling as it goes to the right. Okay, those should be, that's all, like I said, all should be review. A horizontal slope is when you get, excuse me, is when you get a slope equals 0. Actually, I should say horizontal is when the slope is equal to 0. So, and what that means is that there is no rise as it's running the whole time. So when the slope is 0, or you have a 0 in the y direction, it's not going up. It's staying the same. So this would be a horizontal slope, or a slope of 0. And the last one is a vertical slope. So vertical, we would have an undefined slope. Okay, which means that it's only moving up or down. It is not running at all. There's a 0 on the bottom of your fraction. It's undefined because we can't divide by 0. It's not changing in the x direction. It's only changing in the y direction. That would be an undefined slope. Think about it this way. The 0 slope, the horizontal, you can stand on. It exists. If I were to put a person on here, you could stand there. Vertical, you can't stand on a vertical line unless you're Spider-Man, which we are not. So it would be undefined. Alright, so let's do a couple problems. Let's just find, I want to find the slopes, so find slopes. And I'm going to give you the points 2, -4 and 0, -5. And over here, so you guys can pause and do these and try them if you want, and you can, if you want, try that other method if you think that that's something you would like more. Okay, so pause here if you want to see what you can do with these, but I'm going to do them the slope, the jump way. So I'm going to write my points out again. I make my bracket. This is going down 2. This is going down 1. So my slope is equal to -1 over -2, which reduces to, or simplifies to, I should say, 1/2. Alright, so that's all you got to do. Again, you can do it the y2 minus y1, x2 minus x1, but you should get this value here. Now, just looking at this before we even do number 2, notice how the x doesn't change. The x doesn't change, so it is not running. It is not moving from the x direction. That should tell you that if it's only changing in the y direction, it'll probably be undefined. But let's double check. 1, 3 and 1, 7. Sure enough, this goes up 4. This goes up 0. 4 over 0, undefined. So, I would say that the slope is undefined, and I would say I have a vertical line. Okay, let's go to the next page. Now, as the slope gets bigger, I'll change the color here. As the slope gets bigger, think about it numerically. What happens to how steep it gets? You have to think about it. Well, if the number is getting bigger, that means it's going up more y values for the same amount of x's. So before, if the slope was 1, it was moving up 1 and over 1. If it goes up to 2, it means it's moving up 2 and then over 1. So as the slope gets bigger, the line gets steeper. Okay? And it doesn't matter which direction it's going. We talk steep as in slope only. So if it's negative versus positive, it doesn't matter. A steeper negative one would be bigger than the less steep positive one, or steeper. So, all right. So let's try to see which one's steeper. So I'm going to give you an example, which is steeper. We have a line 1 with the points -2, 4 and 3, 5, and we have a line 2 that has the points 1, 4 and 7, 5. So if you want to try to find the two slopes and tell me which is steeper, pause the video now and see if you could do it first. Otherwise, just follow along. I'm again writing the points out so I can do my jumps. This is going up 5 units. This is going up 1 unit. So this slope for this line is 1/5. If I do the other one over here, 1, 4, 7, 5, this goes up 1, this goes up 6. So this is 1/6. Now hopefully you guys know that 1/5 is bigger than 1/6, which means that line 1 is steeper. So line 1 is steeper. Okay, because the slope is bigger. Good. Alright, so 2 more things we'll talk about. We have parallel perpendicular. Parallel lines never intersect. And perpendicular lines, I'll use the symbol for perpendicular, form right angles. So what happens is, for parallel lines, think about it. If it never touches, that means that they have to be rising at the same rate. So the slopes will be equal. So m1 equals m2 for parallel lines. For perpendicular lines, slopes are opposite reciprocals of each other. So the one slope is the opposite reciprocal of the second slope. So you just flip it and change the sign to get the other slope. So let's look and see. I want to know parallel or perpendicular. I use the sign for parallel now. So I want to know, are these parallel or perpendicular? That's my question. And my lines are line 1, which is 1, 3 and 6, 1. Negative 1, I mean. Sorry about that. And line 2, which is -2, -3, and 2, 2. Now, I guess I could also throw a third thing. It could be neither. So let's see what we get. I'm going to do line 1, which is 1, 3, 6, -1. And I go down 4 here, and I go up 5 here. So the slope for line 1 is -4/5. Line 2, I'm going to do -2, -3, 2, 2. This goes up 5. This goes up 4. So the slope for line 2 is 5/4. And if you look at these, this one's a -4/5. This is flipped over and the sign is changed. That means these two lines are perpendicular. So the two lines are perpendicular. Okay. And if they were the same, you would say they were parallel. So we'll work on that in class a little bit more, but you guys should know that. This all should be kind of a review for you. This might not be. So sometimes we ask you to find some variable that gives us a current slope. So find k given the slope and points. Now for this one, it's harder to use that jump method that I've been using just because it's still possible, but I think for right now you guys should just do the y2 minus y1 of this just to be safe. And I'll do it that way as well. But it is possible to do with the jump method also. Maybe I'll show you guys in class. Alright, so I know that I have these 2 points and I'm giving you a slope of 2/3. So this time I have a slope, but I have these points. I want to know what k is that actually makes this true. So I'm going to set up my slope equation. My slope is 2/3, which is equal to y2 minus y1 over x2 minus x1. Okay, I'm first going to simplify this side here. So I have 4 minus k and then plus 10. So this turns into negative k plus 14. Make sure to distribute that negative. Down here, the 2's go away over 2k. Now what you can do is cross multiply and solve. If you guys remember, when you have two fractions equal to each other, you can cross multiply them. So this becomes 4k equals, and then we cross multiply these. Remember to distribute the 3, so it becomes negative 3k plus 42. So we add 3k, so we get 7k is equal to 42. So my k value is equal to 6. Okay, so that is the slope and finding k. Now, if you guys will take a second and go to your note sheet, I have 2 word problems that you guys can try, and then we're going to go over. Okay, so you should be on this page now. It's just the 2 word problems from this section. We're talking about rate of change. So let's look at the first one. You're camping at the Grand Canyon. When you pitch your tent at 1 p.m., the temperature is 81 degrees Fahrenheit. When you wake up at 6 a.m., the temperature is 47 degrees Fahrenheit. What is the average rate of change in temperature? What was the temperature when you went to sleep at 9 p.m.? So the first thing I'm going to do is say that when I'm starting, it's good to label your variables or label where the starting point is. So at 1 p.m. I'm going to call that 0. So I have the point then at 0, I'm at 81 degrees Fahrenheit. So that's one of my points. If 1 p.m. is 0, that means 6 a.m., if you count ahead, should become 17. So that means that I have another point, 17 comma, and then it went down to 47 degrees. So the rate of change is our slope, so we want to find out what this rate of change is. I can really quickly just do that over here with the jump method. This goes up 17, this goes down 34. Okay, so my rate of change is equal to negative 34 degrees Fahrenheit per 17 hours. It's very good to label word problems so you know what you're talking about. So when you solve that, the rate of change is it goes down 2 degrees Fahrenheit per hour. So every hour it goes down 2 degrees. Right, and that's the rate of change. And what was the temperature when you went to sleep at 9 p.m.? Well, now that we know the rate, we know it goes down every 2 degrees at every hour. So if at 1 p.m. it's at 81 degrees, I'm going to take away, well, from 1 o'clock to 9 o'clock when you go to sleep, that's 8 hours. And we're taking away 8 times 2 degrees. You should get that the temperature dropped to 65 degrees Fahrenheit at 9 p.m. Okay, so that's how rate of change works with a word problem. It's the same thing as slope. Find the slope, how much is it changing, and then go from there. Alright, and again, you could have paused and done that, and also you can do that with this one too. Try to pause it first, find the slope. Again, it would be good to probably set your time equal to 0, so I'm going to say 1993 represents 0 in this case. So my points will be 0, comma, 61.48, and 3, comma, 47.70. And again, it's a decrease overall. If you do this, this is 13.78, negative. So my rate of change for this problem is equal to negative $13.78 over 3 years. So dollars per year. So when you simplify that, it's approximately negative $4.59 dollars per year. So that what that's saying is every year the bill went down negative 4.59. So the last part, what would it be in 1997? Well, we know 1996 was 47.7, and then we're going to take away the 4.59 to go one more year later. So you should get 43.11 in 1997. Okay, so that is 2.2. A lot of it is review. It's all about understanding what is changing and remembering your units for the word problems and understanding your parallel perpendicular lines with the slope. We'll go over and practice more of that in class.